So we are continuing on with your biology, and we're in chapter 9. And you have this understanding the living creation here. This is such a sweet way of describing what's going on inside our little cells, each one of our little cells. And we have, millions of them. And the description is so good here. So let me talk about it. ATP, adenosine triphosphate. Look at the word phosphate. You need phosphates for this, but these are in each one of our cells. So the cell needs chemical energy. How do we get our chemical energy? How does the cell make energy? And we found out how it does this amazing process that God put together, and very complicated, but very amazing. Well, the cell breaks down its fluid in very small steps. So we can go through all these steps, and you'd probably be here for a long time. I'd be a long time explaining. But these steps basically are releasing these small, controlled bit of energy in the steps. And this energy is synthesized, or I should say, made by a special phosphorus compound. ATP is a phosphorus compound that's reacting in each one of our cells. And so how amazing ATP is, the energy carrier of the cell, and also the temporary storage. It also carries the energy, makes the energy, and stores the energy in our cell. ATP is called a nucleotide. It's constructed of a nitrogen base. That means it has to have protein in it, right? Made with protein. A nitrogen base has a nitrogen base, so it's this machine. It's working like a machine in our cells. ATP can release energy by breaking a phosphate group off a molecule, and then when they break it off, it forms ADP. Okay, so we have ATP and ADP. So when it breaks off this molecule, a bunch of energy comes out. It's like you break it and this firecracker comes out of energy. So the ATP to the ADP. So when the cell needs the energy, it plugs into the ATP, into the slot where it says to break off, and the ATP is split, and then the energy comes out of that split, and from that energy carries it to the desired process. And after the split happens, the ADP that's already changed and split, as it's changed, it goes back and synthesizes back into ATP. So ATP to ADP, ATP to ADP. That's how it goes. So as it goes back, how does it get back into ATP? It goes into what this is, and we studied that before, mitochondrions. Little mitochondria that are in each cell. These are our energy making. So it goes into these little mitochondria, and some cells have more than one. And these mitochondria manufacture it, bring it back up, so it's ATP again. So now, the ATP breakdown and recombination is so vital to living things. That's how we're living, really. In the physical sense, we need this. And ATP is important in things like muscle contractions. It's important in DNA replication, as DNA and reproducing DNA in cells. And it's also important in almost every living function in our body. How important. So let's go through this. So the energy breaks down the ATP. So you have the ATP here set out. Here's the molecules here. And so what's happening here, the ATP is coming up here. Here's the ATP. It diffuses throughout the cell, and then the energy comes off when you break part of it off. This phosphate's going to break off right here, and then you're going to have this energy come out, and the ATP is broken down in the process, and this energy can come out for enzyme function, for muscle contractions, for ion pumping, all these things the energy is used for. And this little phosphate is separate. Remember, it pumped it off? So now you have these two parts, and now they need to go back in. So now it's ADP because they lost that phosphate. And so now they need to go back into the mitochondria. And here you have this ADP combining in here in the synthesize in the mitochondria, this part of the mitochondria. and going back and producing ATP again, and then we go in the circle again. How amazing is that? Don't you love that we could even know these things that happen in our cells? Just awesome. So let's go on to the next part, and we're going to be talking about micronutrients. And we already said that micronutrients are what? They're tiny, so they're vitamins and minerals that we need. So micronutrients are organic substance found in plants and animals and foods that we eat. And just a deficiency in a little bit of them, if you don't have enough of this vitamin, can cause illness, to be sick, and sometimes even death. If you don't have enough vitamin C, you surely can die. If you don't have enough vitamin B, you can, or maybe even vitamin A. Those things are all needed, and to a certain tiny amount. And so are minerals. We'll talk about vitamins first. If you don't have certain minerals, you don't have enough iron, oh my goodness, your blood's going to be poor in iron, and you're going to be very sickly. And that's a mineral. So let's talk about vitamins first. Let's see down here. Oh, we're almost at the end of this section. So let's talk about vitamins first. Up here. This is where you're in your book. Vitamins are divided into two groups. We have water-soluble vitamins, which are easily eliminated from the body. And water-soluble vitamins, you already learned this. Vitamins are vitamin C and vitamin C, vitamin B, mainly. Vitamin C and vitamin B complex vitamins. So vitamin C you need, it's water soluble because you can take as much vitamin C as you want, although sometimes it kind of irritates your stomach if you're taking too much, because it's water soluble and it's washed out, and so you have to keep replenishing the vitamin C in your body. And the same with vitamin B vitamins. Again, if you take too much, you might have stomach problems or something just because you have too much in your stomach and such, but vitamin B vitamins are that way. But there's a lot of vitamin B. There's 8 vitamin B vitamins. So when you think of thiamine, you think of vitamin B1, which is riboflavin. You think of vitamin B2 is niacin, vitamin B3 is folate, also called folic acid, biotin, pantothenic acid, and vitamin B6 is important, peroxidine, and then vitamin B12. If you don't have vitamin B, I know people that have died of pernicious anemia because they didn't have enough vitamin 12. So it's pretty important to have all these things. And then we have the fat soluble vitamins, which we know are A, D, E, and K. You need to know that those are fat soluble. If you're eating too many carrots and stuff, you might get sick because that has vitamin A, and you might get too much vitamin A, and your skin might turn orange. Who knows? And vitamin D, you can't just take a whole bunch of vitamin D; it will make you sick. And vitamin E and vitamin K are the same things. These are fat solubles because they don't. Fat means they don't wash right out of your body. They're fat solubles. They're insoluble in water, so they don't just wash out. So most vitamins serve as coenzyme. That's that word co, because they assist other molecules to perform certain jobs. Biotin is parts of an enzyme, so it helps the enzymes. That's a B vitamin, biotin. Niacin and vitamin B12 function independently, but they're still used. Niacin in different areas of your heart, niacin and things, and vitamin D12 in your blood. And then we have antioxidant. What is an antioxidant here? Well, antioxidants are very important because they're cleaners. They neutralize harmful free radicals. When you have these harmful substances in your blood and coming into your body, it's important that you have some cleaners. So to clean them out. So vitamin C and vitamin E are antioxidants. So they're the cleaner antioxidants to get those free radicals out. And so as you get them out, it's important. So vitamin C neutralizes the free radicals dissolved in water, because it's water. Vitamin C is water soluble. So It basically gets those out that are in water. And vitamin E, it's a fat soluble, so it gets the free radicals out of your fats and lipids. So you have two. Isn't that weird? God put together, you have two different kinds. Vitamin C working, getting the radicals out of the water part of portion, and vitamin E neutralizing our fats and lipids because they're insoluble in water. So two different vitamin E and vitamin C are radical. They get rid of the radicals, so I call them antioxidants of the free radicals. We don't want free radicals in our body. So going on now to the minerals. You can have a lot more talk about minerals. I have one paragraph on minerals here. So minerals, what are minerals? Minerals are important and they're inorganic. What does it mean they're inorganic? When you say inorganic nutrients, means that they don't have carbon in them. So they are usually elemental, they're elements, so they're different from carbon, but we still need them. What are some that we need? Well, we need calcium, phosphorus, iron, and iodine. Those are very important. Calcium, what does that help? That's in your bones, calcium in your bones, and your collagen in your muscles and such. Calcium is very important, and in your teeth too. And of course, phosphorus, we know that, but your ATP in your cells even having being part phosphorus. Iron in your blood. If you're low in iron deficiency, your hemoglobin doesn't develop right. And iodine, that's actually in your thyroid, very important point in your thyroid, which gives you metabolism. And these are in minerals in your body tissues too. So other important minerals include sodium, potassium, magnesium, sulfur, chlorine. So you need all these things in very small. Chlorine, take chlorine. If you had a lot of chlorine, you took a lot of chlorine and it could kill you. So that's why they call these trace elements. You only need a tiny, tiny bit, tiny trace elements of these. So let's go on. Going on to, let's see, trace elements. Let's see. Oh, I didn't go over these trace elements. We need zinc. Zinc, if you were coming down with the flu or something, zinc is very important because it's a fighter of inflammations in your body. Copper, manganese, selenium, and molybdenum, and chromium are all things. We need these little trace. So these small trace are very important. You can see how the very little bit of iron is needed as hemoglobin, and this protein transports oxygen. So you need hemoglobin, and if you're low in hemoglobin, guess what? When you're anemic, you can hardly breathe. You can't walk long distances. I was very, very anemic with low iron. I could hardly even walk any place without getting my whole body just feeling totally tired, and I couldn't breathe right. It's because my blood wasn't transporting the oxygen that my body needed. So important. And then of course we have sodium and potassium, and they're used to balance out the water in our body. And we know that. We saw that before, how all the sodium come in and all the potassium come in and out, and they change in this. So that's how our water comes in and out of our body with sodium and potassium. They're electrolytes. And so you go have a Gatorade, you're going to have sodium and potassium needing your electrolytes, because you can't just have water, you also need the electrolytes, which are sodium and potassium in your diet. And of course, calcium, we talked about calcium. So let's talk a little bit about water. We could talk all day on water, and they just have a paragraph here too. So water, much of our body is water. 60% of is intercellular, is inside our cells. And then extracellular things like blood. Our water is in our blood plasma and in our lymph system. And in our cerebral spine, in our spine, we have water. And in our joints, all of our joints need water in our joints to be lubricated. Almost all of the chemical activities carried on our body depend on some water. Water is necessary for digestion. We couldn't digest our foods without water. The absorption of our food, we couldn't absorb our food without water. And to transport nutrients to our blood cells. So basically, even water going in our blood and through our body to other sections is transporting water for construction and repair of our cells, for lubricating our joints, and for keeping our body temperature. You know, when you have a fever, you got to drink a lot of water because you need that water to keep your temperature. Now, what if you have too much water? There's a condition where when the body tissues absorb extra fluids and cause you to retain too much water, and this condition is called edema. A lot of times people with pulmonary problems and heart problems, they're retaining water a lot, and they get all water retained and have edema. Edema is too much water in their body cells, and that happens, you'll see with certain people where their ankles are all swollen up and such. So that's the section on our nutrition. It's a quick run through, but it's a good run through on what you actually need to know for health and why you need to eat these things and get these things in your diet. Go forth and be a healthy teenager, okay? I hope you do. I know you will with Jesus' help. In the name of Lord Jesus, we just pray that you give Izzy and Ellie all that they need to be a healthy person and know exactly what they eat. Food is important, and that they eat the right foods and those things for those nutrients and vitamins in their body, and stay healthy in Jesus' name. Amen.